Hello again. Welcome back. This here module, I want to talk about a couple of different things. We'll start with machine guarding. And you may not know this or not, but I hope you do. Machine guarding is what kind of control? Engineering control. It is the number one engineering control. It is the best engineering control. You put a guard in there between the person and the hazard. And if it's a proper guard, there's not going to be an injury. I mean, it's pretty simple. Something have to go bad wrong, or somebody have to do something really out of the ordinary for somebody to get hurt if a machine is properly guarded. So we're going to look at what OSHA says about guards. We're going to look at that from more than just one perspective. This is one of them here, and little icons. And all right, engineering controls, machine guarding. 29 CFR 1910.212, machinery and machine guarding. And we're going to talk a little bit about it. Hazards associated with equipment. The main purpose of guarding machinery is to prevent contact in any part of the human body with the dangerous parts of machines. And most machines have dangerous parts. Okay. Why does it matter? Here we go again, backwards. All right. Why it matters? Again, people get seriously injured, mangled, amputations, and people die. And that's our job, is to not let that happen. And again, being proactive, you put a guard in there. You don't wait till somebody gets hurt and then do something about it. So hazards associated with equipment, unguarded machinery presents basically two types of hazards. Mechanical hazards arising from the motion or operation of the machine, and non-mechanical and hazards related to machine motion, unrelated to machine motion, such as electrical hazards. So if it's not guarded, you can stick your hand in somewhere and get fried too, not just get your hand chopped off. So there's some common safeguarding methods. There's some devices that can be used, sensing devices like a light curtain, pullback mechanisms that actually put a band around your wrist, and when the machine is activated, pulls your hands back. And if of course, if it doesn't, if for some reason your hand's not being pulled back, it'll shut the machine off. Restraints, again, maybe you can't get your hand in there. Safety controls, 2 hands, gates come down, maybe automatically come down when the machine goes, or gates that are interlocked. And these things are usually part of the machine itself, or in conjunction with the machine. Automatic and semi-automatic feeding and ejection systems. A lot of injuries were take the old punch press operators. They stuck something in a punch press, boom. But now you could have it automatic feed into something like that instead of having a person stick their fingers in there. So it limits the involvement of the operator. Location and distance move the hazard out of the reach of the operator, such as placing the operator in a control room, maybe. Safety accessories, push blocks for saws, non-kickback devices on saws too, jigs to hold a part that you're working on or moving it, or to keep your hands away from the point of operation using a jig to hold something. Special tools keep your operator's hands out of or away from the hazard. Special tools. All right, now we're going to look at the actual OSHA regulation, 1910.212, A1, types of guarding. One or more methods of machine guarding shall be provided to protect the operator and other employees in the machine area from hazards, such as those created by point of operation, ingoing nip points, rotating parts, flying chips, and sparks. I find that unusual that OSHA puts all these, like ingoing nip points and point of operation, rotating parts, and then throws flying chips and sparks in there too. But that mean, it's okay. That's what they're doing. But that's just unusual to me. It's the physical things like the ingoing nip points, the point of operation, the ones that are really going to mess you up. Of course, flying chips could do that too. But examples of guarding methods are barrier guards, 2-hand tripping devices, electronic safety devices, etc. It's unusual for OSHA to put examples in there too. They usually leave that up to you. General requirements for machine guards. This is very important. Guards shall be affixed to the machine where possible and secured elsewhere if for any reason attachment to the machine is not possible. The guard shall be such that it does not offer an accident hazard in itself. That makes sense. I mean, but this guard should be affixed to the machine where possible and secured elsewhere if for any reason attachment to the machine is not possible. Why do you think they want it attached to the machine? Well, it's pretty simple, I think, because machines could be moved. I mean, they could, So if it's attached to the machine and you move the machine, you move the guard. If it's not attached to the machine, you're going to move the machine, you're going to have to take off the guard and it might not get put back on. That happens. Point of operation guarding. Point of operation is the area on a machine where work is actually performed upon the material being processed. In other words, if it's a saw blade, it's where the kind of rubber hits the road, so to speak, where the saw hits the wood. If it's a punch press, it's where the punch comes down and hits the piece of equipment. That's the point of operation. And that has historically been where a lot of accidents, amputations happened. So the point of operation of machines whose operation shall expose an employee to injury shall be guarded. The guarding device shall be in conformity with any appropriate standards therefore, or in the absence of applicable specific standards, shall be so designed and constructed as to prevent the operator from having any part of his body in the danger zone during the operating cycle. Now you see they're getting back to this kind of punch press mentality, the cycle. So boom, and it's cycles. And that doesn't always happen in a lot of equipment. It runs all the time, but that's kind of that mentality when they did this guarding thing. They were really worried about this with good reason. And so they're saying here is if there's not a specific standard, it's got to be designed to prevent the operator from having any part of his body in the danger zone during the operating cycle. So this is one of OSHA's ways to get around with to prevent people from getting around the law. So special hand tools for placing and removing materials shall be such as to permit easy handling of material without the operator placing a hand in the danger zone. Such tools shall not be in lieu of other guarding required by this section, but can only be used to supplement protection provided. So they're saying you can't just have it unguarded if you have a tool to push a part, let's say, into the point of operation. So, but you still should use them, but you still have to, doesn't get away from using guards. The following are some of the machines which usually require point of operation guarding. Guillotine cutters, that's just a big knife, it's not like that. Shears, alligator shears, power presses, milling machines, power saws, joiners, portable power tools, forming rules and calendars. So those are all require point of operation guards. I told you about the calendar where the guy got his hands, both his arms crushed. Barrels, containers, and drums, revolving drums, barrels, and containers shall be guarded by an enclosure which is interlocked with a drive mechanism so that the barrel, drum, or container cannot revolve unless the guard enclosure is in place. Now here they're telling you, they're getting real specific about it. It's got to be interlocked with the drive mechanism. So it can't revolve unless the guard enclosure is in place. Now it doesn't say electrical interlock. It could be mechanical. It could have a part that goes down there and stops something. But it has to be interlocked. So if the guard's not in place, the barrel or drum won't rotate. Exposure of blades. All right, this one is really, really common. You would think it's not nowadays, but you'll find it. When the periphery of the blades of a fan is less than 7 feet above the floor or working level, the blade shall be guarded. The guard shall have openings no larger than 1/2 inch. Surprisingly, I have still found old fans that have the big openings in them in businesses 50 years after OSHA. So again, if the periphery of the blades of a fan is less than 7 feet above the floor or working level, the blade shall be guarded. The guard shall have openings no larger than 1/2 inch. 7 feet. Remember that, okay? 7 feet above the floor or working level or working surface. Remember that because that's in a whole bunch of regulations. And I'll give you my little regulation at the end of this thing. Anchoring fixed machinery. They will write, OSHA will get you for this. When machines designed for a fixed location shall be securely anchored to prevent walking or moving. They wrote this up for a drill press in a shop that wasn't bolted down. Now, the base of the drill press has holes in it where you could do it, and it's not going to be going anywhere else. It's in the shop. I mean, it wasn't portable. It's in the shop. And this is one of those things that's maybe it's an infraction, but it's not a hazard. That drill press is used sporadically. Those maintenance guys do have to drill on something. They use the drill press. And it's not going to walk out the door. It's not going to knock somebody over. I mean, if it moves a couple of inches in the course of a couple of 6 months, Who cares? You just move it back. But they wrote us up for it, so we pulled it down. But that's the regulation, so you ought to know that because you will see it. Trust me. Here's my simple rule for guarding. If it's within 7 feet of the floor or the work surface, you can touch it and it can hurt you. It should be guarded. Now, you won't find this exactly like this in OSHA regulation, but you will find the 7 feet. And I actually had this, I think I had this printed on the back of my business card or something like that. And I would tell the plant managers or the management, say, well, what is the rule? They'll be talking about this, and they say, well, what's the rule for guarding stuff? And this is it. It's pretty simple. In 7 feet of the floor work surface, you can touch it and it can hurt you and guard it. Why wouldn't you do that? Regulation or no, why wouldn't you do that? Just common sense. General requirements for guarding design: affixed to the machine and securely attached. Okay. Prevent contact between body parts of the machine hazard, which kind of recaps stuff here. Tamper-resistant design to prevent removal or disengagement. I mean, if the operator can just open the guard up, what's the point? It's got to be something that's got to be a little bit of an effort to move that guard. Now, maintenance people will have to remove the guards most likely to work on a machine, and that's why you got your two biggest protection on a machinery is guards when the machinery is running and lockout when it's not. Durable construction, they can't be just, they have to be able to handle it. They got to be durable. Protect workers from flying objects. Sometimes that's okay. Does not create new hazards. Does not create interference with the process. Of course, you can't do that. Allows for lubrication and maintenance. That's good. There's ways you can do it. You can have a line going down for oiling and stuff like that. There's a lot of ways you can allow for lubrication and maintenance and still have a guard. So that's very possible. Allows for ventilation. Machines build up heat. That's why this expanded metal is probably the favorite of guards, because it does allow for view of whatever you're looking at, whatever's in the machinery. You want to look at the machine, see how it's going, see what's running, see if everything's okay. And you want air to get in to keep it cool. Grinders. Yes, everybody has grinders in their shop. You might have one even at home. And I suggest what you do is find a picture like this or similar while on the internet, laminate it and stick it up wherever you have a grinder so that nobody can say, I didn't know. Okay. Choose to check openings between the grinding wheels, tongues, and work rests to meet OSHA and ANSI safety standards. The tongue at the top is maximum 1/4 inch from the wheel, and the work rest an 1/8 of an inch max opening between it and the wheel. Now, as that wheel wears down, you got to move those guards. What's the tongue for? The tongue is to prevent that wheel, if it malfunctions or fractures, it's going to come flying out of there like a bullet. So that tongue is to keep that from hitting the operator. That's what it's for. And it happens. The work rest, keeping it close, because if it's not, you could be working on something. If it's too far away, they could pull it down in there, whip it around, come back at you. That happens too. So now you notice there's nothing on here about eye protection. There's no, they have them, most of them have something comes down, and usually they get so filthy and crappy after a while, you can't even see through them. But there's nothing on here that says anything about eye protection, but you should be wearing eye protection when you are using these. Right? So don't take a grinder for granted. They can be pretty hazardous. My boss at OK Foods, husband working for AOG, I believe, and he was using a wire brush on a grinder, just the wire brush thing. And according to what I heard, he said was, I just picked it up for a second, looked at something, and he felt like he had something in his eye. And he went home and it kept feeling there's something in his eye, but he thought, it'll go away, And the next day it was still to bother him. And he went and one of those wires came out of that brush and went in his eye, and he lost his eye over it. So don't take anything ever for granted in safety. We got written up by OSHA at the Carson plant in California for one of these, and I'd go to that plant frequently, and I'd go back there in the shop and I'd see that thing be out of adjustment. I got tired of talking about it, and I've told this story before, but one day they were in a conference room, and the vice president was of operations or production. And I walked in the conference room and I slammed something down on the table. I said, "There you go. This won't be a problem anymore." I cut the plug off. I just used my pocket knife and cut the plug off of that sucker. That got their attention. Never had a problem with the knife for that. Rotating shafts. If it's smooth, it may project not more than 1/2 the diameter. So if you have a shaft that's sticking out, and frequently they do, and if it's smooth, well, there's no burrs on it, there's no keyway is the most common thing in a shaft that's going to get you on this. But if it's smooth, it can project, but not more than a 1/2 inch diameter. So if it's a 1 inch shaft, only 1/2 inch. So it's not very much. Now, if it's not smooth, it has either a keyway or burrs or anything on it that is not smooth, they must either cut off flush or covered up with a cap. They'll get you on this too. Like we're written up for a shaft that was sticking out, and it was on a piece of equipment that was very slow. It was a wooden slatted belt that at the end of a line of polyester fiber fill, and it was moving very slow. In fact, this was a guy that came into the Carson plant. He used to work in the ocean inspector in the aerospace industry, which is pristine kind of environment. He gets into a fiber plant, and he probably thought he was in hell. Anyhow, and there was a rotating shaft, and it turned at like 3 seconds for a resolution of 20 revolutions per minute. Now that is not hazard. You're not going to get caught on that. That's going too slow. It's not going to catch your clothing or anything on it. So I didn't bother with it, and he wrote us up for it. And then we went to the initial the conference with OSHA over it. And this, I'll try to hold my tongue here, person said, "Oh, it was moving so fast, it was blurred in the picture." Well, his entire picture was blurred. In fact, I think his brain was blurred. And they didn't buy it because if it had been moving so fast, this contraption that was on, this kind of homemade roll-up thing would not have survived at speed like that. I mean, it just wasn't designed for it. So sometimes OSHA can be really butt heads. All right, double insulated. What does that mean? How can you tell if a tool is double insulated? That's how you can tell right there. One of the very first OSHA inspection was like 1973 at a drapery plant in New Martinsville, West Virginia. And guy looked at an iron we had, and he was, "Oh, this is had a 2-prong plug on it." And he said, "Oh, there's no ground pin on this. Oh, write it up." And I said, "Wait a minute. We just went up to Kmart and bought this iron. Anybody can go and buy this iron. You can buy one there. So how can this be an OSHA violation? Why are they even selling it then?" And he backed off. And then he said, "Oh, it must be double insulated." He didn't write me up. But now I know. You look at this, you go into Lowe's or Home Depot and you look where all their power tools are. They have a great big power tool thing. And you'll see some power tools in there that don't have a 3-prong plug. But then you look at the nameplate on it and you'll see that. Trust me on that. You will. Any question regarding hazard machine guarding? Of course you don't. How about that? What's my favorite question to ask? I told you that one already. Yeah, I hope you have figured this out by now. What's the capital of North Dakota? Don't know that one, do you? All right. Be safe. Sink to Bismarck.